Hey, welcome back everybody. It's Mr. Geist, the Science Geek, and today's objectives are to differentiate between cohesion and adhesion, to be able to provide real-life examples of adhesion and cohesion and how they are being used, and identify other properties of water. First, let's take a look at adhesion versus cohesion. What are the differences between the two? How are they similar? Remember that we are always looking at water in these examples. Adhesion is the attraction between molecules of a different substance. If you have an adhesive, it's usually the tape sticking to some other surface, such as a wall or any other surface really. Think of where you put Velcro. You have one part of the Velcro that has little fuzzies and the other part of the Velcro that is, more firm gripping. And when both are put together, they stick together. So it's the attraction between different molecules, alright, different substances. If you take a look here, we have a windshield in water and we have a blade of grass in water. Alright, the attraction is between the water and the windshield, two different substances. In the water and the blade of grass, two different substances. On the other hand, we have cohesion. This is the attraction between molecules of the same substance. So water molecules sticking to other water molecules. So the water molecules on the windshield sticking with other ones, making big blobs of molecules. Alright, and the grass, you have the water on the grass molecules. Alright, and you can see the different sizes in the water molecules because as more water molecules attract to one another, it's going to make a bigger blob of water. So that is the difference between cohesion and adhesion. Adhesion, unlike substances attracting to one another. Cohesion, like substances attracting to one another. Our next water property is capillary action. Capillary action is a phenomenon where liquid spontaneously rises in a narrow space, such as a thin tube or in porous materials. Everyone loves to play with straws. I remember growing up as a kid, I would take my straw, plug the end of it as it was in my soda that I got from McDonald's or anywhere else I would get a fountain drink, and I would see how much soda I could keep in that straw by plugging the tip of it. This is kind of the same thing. In your capillaries in your body, blood goes through, and as we stand up tall, right, blood needs to work against gravity, so it needs to work in our capillaries. The only way that this happens is through adhesion and cohesion. If we take the straw and the soda example, the only way that we can explain that liquid rising in the straw going against gravity is because the soda molecules are attracted to one another and they stack on top of one another, and also the soda molecules are attracted to the side of the straw, which allows that soda to go upward against gravity in a soda. So capillary action is a phenomenon where liquid spontaneously rises against gravity. Our next water property is surface tension. Surface tension is a property of the surface of a liquid that allows it to resist an external force. In this picture we have a water spider and we have a body of water, whether it's a pond or a slow moving water in a stream or in a lake, it doesn't matter. We have a water spider and a body of water. In this example, cohesion and adhesion both fit into this equation. For the water spider, we have molecules on the feet of the water spider that are attracted to the water molecules of the body of water. This is the adhesion part of the equation. The cohesion part of the equation is the water molecules in the body of water attracted to other water molecules. This makes a little false blanket going over the body of water, which is strong enough to hold up the water spider. The next property of water is the pH scale. This scale shows how acidic or basic a substance is. Another name for basic is how alkaline it is, or alkalinity. As the numbers get higher, it's more basic. As the numbers get lower, it's more acidic. If we take a look at some common household items such as lemon juice and vinegar, we can see that they're more on the acidic side, whereas ammonia or milk of magnesia is on the basic side. If we take a look at milk or regular tap water, it should be more neutral, somewhere around the 7 mark. Sometimes in real life situations, we must use buffers to control the pH of a solution. A buffer is a weak acid or base that is used to change the pH of a solution in small increments, very small increments. For example, if you know someone who has a pool, or if you have a pool yourself, whoever takes care of that pool might test the pH of that pool to see if it's prone to grow algae or that green scum that grows on the side of the walls of the pool. If the test is either too acidic or too basic, we can add a buffer that will slowly change that pH to make it resist growing the algae or the green scum that is on the side of the pool. There are two parts of a solution. You have the solute and the solvent. The solute is the substance being dissolved in a solution. The solvent is capable of dissolving another substance or solution. In this example, we have sugar water. The solution is sugar water. The solute is the sugar. That is the substance that's going to be dissolved into the solvent, which is the water. Sometimes in solutions, we have something called a suspension. A suspension is a condition in which particles do not dissolve into the solvent. So if you have things floating around in your solution, that is called a suspension. On the left, we have a solution. The particle is completely dissolved into the solvent. On the right, we have a suspension. The particles did not completely dissolve into the solution or the solvent, and therefore are floating around, and this is called a suspension. In today's objectives, we took real-life examples of adhesion and cohesion. We were able to differentiate between the two. Please remember that cohesion is the attraction of like molecules, where adhesion is the attraction of unlike molecules. You could take a look at the prefix co and remember that it means like. Ad means unlike or different. So in cohesion, we have two like substances attracting to one another. In adhesion, we have two different substances attracting to one another. We also identified other properties of water, such as surface tension, capillary action, pH, and buffers. Please bring any future questions to class so we can go over them as a group.